Hello, this is Ms. DB, and today we are going to continue with Chapter 6 on polynomials, and today we're going to learn how to multiply polynomials. We're also going to learn how to do binomials that have an integer exponent, like if you have x plus 3 to the 5th power, you could write that x plus 3 times x plus 3 times x plus 3 times and so on, but that's going to take a long time to actually do that multiplication, so we're going to learn another method. To multiply a polynomial by a monomial, remember monomial has just one term, we're just going to use the distributive property and our rules, our properties of exponents. So here's some examples. If we have 4y squared times y squared plus 3, that means that we are going to take the number in front, the term in front, 4y squared times y squared, and then we'll take 4y squared times 3. So when we multiply 4y squared times y squared, remember our rules of exponents say that if you multiply with the same exponents that have the same base, then you add their exponent. So we will get 4y to the 4th, and then when you multiply over here, there's no y term on the 3, it's just a constant. So you only multiply the 3 times the 4. That does not change the exponent on the variable at all. So we just write 4 times 3 is 12, so 12y squared. This is our final answer. You cannot combine these because you have y to the 4th and y squared, and you just leave it just as it is. So you're not going to be getting, nice, neat little number answers for these problems. You'll just be getting a somewhat simpler expression. Okay, in B, we're going to take fg times f to the 4th, and then fg times 2f cubed g, and then so on. Now, feel free to write as much of this out on paper. You don't have to turn in all your work for this, but you might have to write it out in order to see what the rules of exponents are. So in the first multiplication, you're going to take fg times f to the 4th. I'm going to do it over here. Fg times f to the 4th. Now we have two that are the same base, the f and the f. The f really has an exponent of 1. And the rule is that when we're multiplying, we add their exponents. So this would equal f to the 5th times g. So that's what the first term will be, f to the 5th times g. The second one, I have fg times 2 f to the 3rd g. All right, that's a lot going on in just this little multiplication. The 2 will get written in the front because there's no number to multiply it with in the first part. Then we need the f to the 1 times the f to the 3rd. That's f to the 4th. Then we need the g times g. G times g, that's g squared. Then we have, so that takes care of this part. Then we have minus fg times 3f squared g squared. Well, that's f to the 1 and g to the 1. So we have f to the 1 times f squared. The 3 gets written in front again. So that's f to the 3rd. Then we have a g to the 1 and g squared, that's g to the 3rd because we're adding the exponents. So let me write down what I have here. The first one was f to the 5th g. The next one was 2 f to the 4th g squared. This one's a minus because of this minus. 3 f cubed g cubed. Let's see if we can do this one without writing it off to the side because I'm running out of room. We have f to the 1 and f to the 1. They're same base, so we can add their exponents. Then we have g to the 1 and g to the 3rd. That would be g to the 4th. Now, the only last thing to check is that none of these are the exact same exponents on the same variables, but we don't have any. F to the 5th, there's no other f to the 5th. F to the 4th, no other f to the 4th. So, yep, there's none that are the same. So this is our answer, as long and complex as it looks. That is our product after we multiplied. All right, here's the problems that are on your worksheet, and we'll do an example. Let's do number 3. So number 3 says negative 6x squared times x to the 3rd plus 7x squared minus 4x plus 3. So we need to multiply the monomial in front by each and every term inside the parentheses. So I'm going to write my work down here. So I'm going to have negative 6x squared times x to the third. And then it's a plus, but I'm going to be, that negative has to stay with the 6x squared. So 7x squared. Oh, here I've got a minus and a minus. So I guess I can write minus 6x squared times minus 4x. That term's going to end up being positive because of the negative times negative. And then I have negative 6x squared times 3. So when I multiply the negative, each one of these terms will be the opposite sign as what they are now. So we have negative 6x squared times x cubed. Remember that we are adding the exponents. When you're multiplying like bases, you add the exponents. So that's negative 6x to the fifth. I'm going to write this as minus. 6 times 7, those go together. 6 times 7 is 42. Now look at the exponent. They're both x's, same base, and we have an exponent of 2 plus the exponent of 2. So that will be x to the fourth. All right, next, like I said, this one's going to end up being a plus because I have negative 6 times negative 4, which is a positive, a plus 24. Then I have x squared times x. X squared times x is x to the third. Remember, when you multiply, you add the exponents. And finally, I have minus 6 times 3 is minus 18, and then just rewrite the x squared. And then I'm just going to check that none of the exponents on my variable of x are the same. They're not. So then this is my final answer for number 3. All right, if you have two polynomials, so the difference here is that this is a binomial multiplied by a trinomial, you have to do the distributive property twice. This one's more work. So we're going to multiply x by every single term in the parentheses, and then we're going to multiply the 2 by every single term, and then we're going to look and see if any of there are like terms so that we can add them together. All right, so here we go. First, we will take the a times each of the terms inside the second parentheses. So we'll multiply a times a squared, and then a times negative 5a, and then a times 2. And then we will multiply the negative 3 times every term. And we just write this as one long thing. So we'd have negative 3 times a squared, minus 3 times negative 5a, and then minus 3 times 2. Now we just go ahead and simplify. So a times a squared is a to the third. Add your exponents. Then put the minus 5 next, and then a times a is a squared. A times a is a squared. And then we have a times 2. We write that as 2a. Then minus 3a squared. Just write that out. Then we have negative 3 times negative 5. That would be a positive 15. Negative times negative is positive, and then just write the a after it. So 15a. And then negative 3 times 2 is minus 6. Then the last step is just to look and see if there's any like terms. I see this is a squared and this is a squared. Also, this is an a and this is an a. So there are some like terms here that we can combine. So negative 5a squared minus 3a squared is negative 8a squared. Just combine the coefficients in front. And then 2a plus 15a is 17a. And then we had to just drop down the a cubed, and the minus 6 just gets written at the end. This then is our final answer for this problem. Lots of work for these. So don't worry if you think, wow, there's a lot of writing here. There is a lot of writing, and it's okay. If you just do it methodically, each step is not difficult. It's just that there's kind of a lot of steps to finish one problem. All right, here's another problem. Let's just practice this a little bit and see if anything interesting comes up. We're going to do this one another way. There's more than one way to do this problem, just like there is more than one way to do many math problems. Let's try it vertically. You're going to write the longer polynomial on top. And so in this case, that's the second polynomial. And it helps to write it in standard form. And standard form just means you put the term with the highest exponent, the highest degree, first. So we're going to rewrite this as a squared minus 5a plus 2. And then underneath it, write the binomial, the a minus 3. And we're going to be multiplying these together. Very similar to the way that you multiplied in elementary school when you did something like 45 times, I don't know, 10. Let's do it by 11, so I have a number here. And you would take 1 times 5 and 1 times 4, and then you'd use a placeholder, and then you'd go 1 times 5 and 1 times 4, and then you would add. So it's similar to the way you did multiplying numbers when they were 2 digits or more, and you did it vertically like this. All right, so we're going to start by multiplying by the negative 3. So we're going to go negative 3 times 2 is negative 6. And then we go negative 3 times negative 5a, these two, and that's 15a. And then you go negative 3 times a squared, and that's negative 3a squared. All right, next we're going to multiply by the a. Notice we leave a placeholder here. You can put a plus 0 here if you want. So a times 2 is 2a. So we want the 2a to be lined up with the 15a, so our like terms are together. And then a times negative 5a is negative 5a squared. And then a times a squared is a cubed. Now we just add vertically, add these together. So a cubed, there's nothing up here to add it to. Negative 3a squared minus 5a squared is negative 8a squared. 15a plus 2a is 17a. And then the minus 6 just gets dropped down. There's nothing to add to that. So that's how you do it vertically. So that works pretty neat. Is this the third way? Yeah, this is the third way. This is using a table. This way is really helpful if you have more than a binomial by a trinomial. Like in this example, we have a trinomial times a trinomial, 3 terms times 3 terms. That's a lot to multiply. So what you do, they already have all the answers in there. What you do is you need 3 terms by 3 terms. So I need a table that has 3 columns and 3 rows. And then up above here, I would write one of the terms. It doesn't matter which one you put where. And on the side, I will put the other polynomial. And then you multiply inside each box. So I'm going to go y squared times y squared is y to the 4th, and the product goes inside the box. And then I'll go y squared times negative 7y is negative 7y cubed, and y squared times 5 is 5y squared. Then I just drop down to the negative second row in the first column would be negative y cubed, negative y times y squared, and then I go negative y times negative 7y, negative y times negative 7y. That will be a positive y squared. Remember, y times y is y squared. And then I go negative y times 5, which would be negative 5y. And then I have one more row to go. Negative 3 times y squared is negative 3y squared. Negative 3 times 7y would be 21y. And then negative 3 times 5 is negative 15. So now I'm just going to look for like terms. These are all of my terms. There's 9 of them. There's a lot. There's only one y to the 4th. That one's done. I can write that one down. Y to the 4th will be part of my answer. Go back and find some more like terms. All right, there is this y cubed and this y cubed. They're going to be in the same diagonal. So I have negative 1y cubed minus 7y cubed. Negative 1y cubed minus 7y cubed. That's negative 8y cubed. All right, let's look for some more like terms. I didn't mean to do that. Let's see, how about blue? We have negative 3y squared plus 7y squared plus 5y squared along that diagonal. Negative 3y squared plus 7y squared. If they're positive, you put a plus. Okay, so I have negative 3 plus 7 is 4. 4 plus 5 is 9y squared. Okay, and then we go to the next diagonal. 21y minus 5y. 21 minus 5 is 16. Positive 16y. And then I just rewrite the minus 15 at the end. That one doesn't have any like terms. And that will be the product of these two trinomials multiplied together. So using this table was a really nice way to get that all organized. We make sure my answer is the same. Looks good. All right. Here is the problems from your worksheet. So there is some where you multiply horizontally, and then there's a couple where you do vertically, and then you can use any method you want. Now I don't have any on here that are a trinomial by a trinomial, but number 9 is a binomial by a 1, 2, 3, 4. It has 4 terms, so that one you might want to try the table method. So on the horizontal one, number 5 is already started for you. Remember, you're going to use the distributive property twice. Let's do number 6. We're going to, it doesn't matter if you do A times each of these and then B, or if you do B first and then A, but I'll just go A. So I'm going to multiply A times each term in the parentheses. So that's A times A squared plus A times AB plus A times negative 4B. Now you're not done after that because you also have to then do the B. So that would be B times A squared, and then B times AB, and then plus B times negative 4B. Now these are all terms separated with plus or minus 1 term, 2 term, 3 terms, 4 terms, 5 terms, 6 terms. You can tell how many terms you'll have by multiplying how many terms are in this one times how many terms are in this one. There's 6, so it's going to be 6 terms. But there might be some terms that will combine. You might have some like terms when we're done. All right, now we are going to go ahead and simplify each of these little multiplications. So we have A times A squared, that's A cubed. Then we have A to the 1 times A to the 1 times B to the 1. So that's A squared B, or B to the 1 if you want. Then we have A times negative 4B. Well, I'm going to put the negative 4 first, then the A, then the B, alphabetical order. You also could just write, instead of plus negative 4, you can just write minus 4 here. And this is already simplified, but I'm going to rewrite it in alphabetical order. All right, here I've got 1A, and then B times B is B squared, so AB squared. And then this one I'll go ahead and write this as minus 4, B times B is B squared. Now I said you might have some like terms. I don't think you do though. We have A cubed, A squared, A. Oh, here's another A squared. There is some like terms. A squared B, A squared B. So those two can go together. And then we have AB squared and minus 4B squared. These are not like terms because one has an A and one doesn't. But these two are like terms, so we can simplify a little bit. We can do this as A cubed plus 2A squared B. This is one of them, and this is another one. Minus 4AB plus AB squared minus 4B squared. I think I got everything in there. And then there's no like term, so then you would be done after that. Okay, number 7, you'll be asked to do the vertical method. Let's look at number 8. So I like to start with, I like to kind of work backwards, you know, like the way we did when we learned how to multiply vertically. And I'm going to go negative 1 times 1 is negative 1. Negative 1 times negative 3y is a plus 3y. And negative 1 times y squared would be negative 1y squared, or negative y squared. Then for the next row, I'm going to do y times each one. So y times 1 is y. I'm going to put a placeholder here because I want to line the y up with the 3y above it. And then I have y times, that was a negative 3y, right? Yep. So y times negative 3y is negative 3y squared. And then y times y squared is y cubed. And now I'm ready to add together vertically. So -1, and then 3y plus 1y is 4y. And then negative y squared, that's the same as -1y squared minus 3y squared is -4y squared. Put a plus if it's a positive. So 3y plus y is 4y, and all I wrote was 4y, but then it was like I was missing a sign here. So I put a plus here. And then y cubed is the only one that goes with that one. So that is multiplying vertically. And then on this one, I want to try with number 9, I want to try the table method. So let's see, I'll do a table that is 2 columns for the binomial and 4 for the polynomial with 4 terms. Okay, so this is p plus, is that a q? P plus q. And then this one is 4p squared, I should put a plus here, minus p minus 8q squared minus q. Now inside the table, we put the products of the row times the column. So 4p squared times p is 4p cubed. And 4p squared times q would just be 4p squared q. So you see, each little individual product is not a very difficult multiplication, as long as you remember your rules of exponents. Okay, then I go negative p times p, that's negative p squared. And negative p times q is negative pq. And then negative, I don't know why I'm switching colors. They're not going to be like terms or anything, but this would be negative 8pq squared if you write it in alphabetical order. So I put the p after the number and then the q squared. And then I would have negative 8q to the third. All right, and then I would have negative, I'll switch back to green to make it look symmetric, but again, these aren't like terms or anything. They're just to help me keep it straight. This would be minus pq, and then that would be minus q squared. Now this time, there's no diagonals that are like terms, but we can still find some. There's no other p cubed, p squared q. Is there any other p squared q's? I don't think so. There's no other p squared, but there is 2 of these. Is that the only like terms we have? I do believe. So then when you write it out, you can't leave it just in the table. You still have to write out your solution. It would be, I'll start with the 4pq plus 4p squared q minus p squared. Now I'm going to put the 2 yellow ones that I circled. That would be minus 2pq minus 8pq squared, my goodness, minus 8q cubed minus q squared. I just barely was able to fit that in there. So yeah, that's a long one to multiply, but kind of fun to do in the tables. All right, now if you are going to expand the power of binomial, one way to do this is to write out what this means. A plus 2b cubed means a plus 2b times a plus 2b plus a plus 2b. And then you have to multiply 2 of them. You remember how to multiply? You FOIL. So I'm going to multiply the last 2. A times a is a squared. A times 2b is 2ab. Middle term is also 2ab. So then I would have 4ab. And then the last times last would be 4b squared, or just do the distributive property twice. Now I need to multiply the first one by the second one, the binomial by the trinomial. So I have to multiply everything in the second parentheses by a, and then everything in the second parentheses by 2b. So you do all that multiplication, and then you look for any like terms. And there is some like terms. There's 4a squared b and 2a squared b. And there's 4ab squared and there's 8ab squared. And that's it. So you combine your like terms and then that's your final answer. So that one is a little bit lengthy. Here's another example. You multiply two of the terms together, and then you multiply the binomial by the trinomial, and then finally you combine your like terms. Okay, we have another way of doing these, and it's using Pascal's triangle. So the coefficients of the variables in our answers, the 8 and the 12 and the 6, and here in this other problem we did, these numbers, the 1, the 6, the 12, the 8, these numbers in front, the coefficients, have something to do with Pascal's triangle. And each row of Pascal's triangle gives the coefficients of the corresponding binomial expansion. All right, so here's Pascal's triangle. You start with 1, and then 1, 1, and then you add these two together, and you get 2. And the outer diagonal is all 1s on both sides. And then to get the 3, you take 1 plus 2 and get 3, and 2 plus 1 and get 3. And then you'd add these together to get 4, and these together to get 6, and these together to get 4, and so on. So Pascal's triangle, you can keep adding rows just by adding these together. 1 is always on the outside, and then you would just add these together. This would be 15, this would be 20, this would be 15, this would be 6, and this would be 1. That'd be the next row. Those correspond to the binomial expansion. If you're taking a binomial and have it to an exponent, then this would be 1, 2, 1. See, it matches with the third row of the Pascal's triangle. And then this would be 1, 3, 3, 1, matches this, 1, 3, 3, 1. Now you still have to do the multiplication or the squaring, or take it to the exponent, because a and b are going to be different values depending on what you're starting with. All right, so here's the steps you're going to do, but we're going to go ahead and look at an example. All right, let's see. So k minus 5. Now we could write k minus 5 times k minus 5 times k minus 5, and we could multiply two of them, and then we could take that answer and multiply that by k minus 5. But using this method is easier, or shorter anyway. All right, so this is the third to the third power. So we want the third row in Pascal's triangle. This row doesn't count. This is the 0 row. It counts, but it's a 0 row. This is the first row, second row, third row, fourth row. Okay, so the third row has the coefficients 1, 3, 3, 1. So then after we look at that, then we know that we're going to be using the 1, 3, 3, 1. Those are the coefficients. All right, so we kind of remember that, or circle it, or write it down on a piece of paper. All right, the next thing to do is to go back and look at the table on the third row. Tells us that this is the pattern that we're going to be using. A cubed plus 3a squared b plus 3ab squared plus b cubed. And in front of each of those is the numbers 1, 3, 3, and 1. So we look at that and we say, okay, that's a pattern. It's like a rule, a formula that we can use. In our example, this is our A and this is our B. And B is a negative, I guess. Okay, so A is equal to K and B is equal to negative 5. And it's going to be 1a cubed. And if you want, you can do b to the 0, but that's just 1. Plus 3a squared b to the 1 plus 3ab squared plus 1b cubed. And you could write a to the 0 here if you wanted. So you see that first we start out with the first variable, a cubed, and then we square it, and then it's just to the 1 power, and then it's to the 0 power. So they're decreasing. At the same time, the other term, in this case negative 5, but our b, is increasing from 0 to 1 to 2 to 3. All right, so we are going to use, every time we see a here, we're going to put k, and every time we see b, we'll put negative 5. That's where they got these I'm going to do it by hand instead of do it step by step. All right, so here's our formula to use. A is k. So I'm going to write 1k cubed. Now, you can write b to the 0, which would be negative 5 to the 0, but anything to the 0 power is 1. So why write it? Then we're going to write plus 3a squared. Well, a is k, so k squared. Now we need our b, which is negative 5, and it's to the 1 power, so you don't really have to write that. Okay, then I'm to this term, 3a, a is k, b squared, that's negative 5 squared. Okay, one more term. It says 1a to the 0. That's k to the 0, but that's just 1. So you don't have to write k to the 0. And then I need b cubed, which would be negative 5 cubed. Now all we have to do is simplify this. So you can't really simplify the first one. But the second one, we could write this as, multiply the numbers together, 3 times negative 5, and you get negative 15, and then write your k squared. And then our next one, we have 3 times, first we have to multiply negative 5 squared. We have to square that. That would be 25. And then in the last one, I need to take negative 5 cubed. That's 125. I still have to finish simplifying the middle, or that third term there. So I'd have k cubed minus 15k squared plus 75k minus 125. And that is my final answer using the binomial expansion. Now, nice that the next one is also the third row because it's to the third power. So this is the exact same formula to use that I used in the last problem. So we can practice a little bit. This one, same exact one, where our coefficients are 1, 3, 3, 1, and these are how our terms are going to work. But this time, a is equal to 6m, and b is equal to negative 8. And then you just plug those in, and you will get your solution. So you can ignore the stuff written on top of the last one, but here is how this will simplify to. And you can practice on your own paper and see if you get a similar, well, the exact same, or if you made a mistake somewhere. All right, here is your worksheet. Let's try a couple of these. So number 11 and 14 are both to the third power. 14 is going to be extra credit. I didn't write it on the worksheet, but that one does take a little longer because it's 5 times your binomial expansion. So let's look at number 12 because we didn't do one to the fourth power. No, let's look at number 13. That one's squared. That's not going to be so hard, is it? Let's do number 12. Number 12 is to the fourth power, so it's this row right here. Our a is going to be our x, and our b is going to be negative 4. Here's our coefficients, 1, 4, 6, 4, 1, but they already put those in here, 1, 4, 6, 4, 1. So what we're going to do for number 12 is we are going to use this formula, except wherever we see an a, we'll put an x, and wherever we see a b, we'll put a negative 4. Whoa. All right, so a is x. Why does it keep turning the page? So we will write... It really doesn't want me to finish this problem. Come on. I'll try grabbing my pen again. There we go. Okay. I'm going to put it down here. I have a little more room. So I need 1a squared, but a is x. So I have 1x, not to the squared, to the fourth, plus 4 times a cubed, but a is x, cubed, b, and b is negative 4. Okay, so I did this one, and I did this one. Now I need the next one. It says plus 6a squared, and that's just x squared, times b squared. b is negative 4, so I have to square that. Did that one. Okay, now I'm on this one. Plus 4a, a is x, b cubed, and b is negative 4. Okay, last one, plus b to the fourth power. Now we simplify each of these terms. 1x to the 4th is simplified already. Next term is 4, multiply your numbers together, your coefficients. We have 4 times negative 4. So that's the same as minus 16x cubed. Then we have 6 times negative, oh, no, I don't. I can't do the 6 times 4. I have to first do the exponent. So negative 4 squared, stop, it doesn't want me to finish. Negative 4 squared is 16 because negative 4 times negative 4 is a positive 16. So then I have to take 6 times 16. That's a big number. 36, 96. So I'd have 96x squared. Now over here, I have 4x times negative 4 cubed. Negative 4 cubed, and you can check on your calculator. Let's see, 4 times 4 is 16. Times 4 is 64. So this would be a negative 64. Oh, just this part's negative 64. And I still have to multiply that by 4 because of the 4. So we have 64 times 4, 24, 25, 256. So minus 256x. Don't forget your x there. And then finally, I have 4 to the 4th. That's also 256. And it's positive this time because I have a negative number to the raised to an even exponent is positive. So I have x to the 4th minus 16x cubed plus 96x squared minus 256x plus 256. And your x term, your exponents on your variable should decrease, and they do. And your numbers in this case is the b, so that should be increasing, and it does. So there you go. Good luck, and please let me know if you have any questions. Try to have a little bit of fun with this one. It's like lots of little multiplications, and just be careful with your exponents. Thanks a lot, and have a wonderful day.